Hi, everybody. We are back and we are continuing our discussion of how to utilize that standard normal table to solve some problems related to calculating probabilities underneath that normal distribution curve. We had wrapped up last segment looking at a specific case of a lower tail situation where we had to find the table value and then we had to add 0.5 to account for all this area on the left half of the mean here. So that was what we had concluded last time with. We're going to jump into a case study in this segment, and we'll kind of move back and forth between the case study and this core example here where we had a mean of 8 and a standard deviation of 5. So let's jump into that case study. And the case study involves a sushi restaurant that is to purchase salmon every day for freshness. They don't want to buy too much salmon because then they're going to waste a lot of their inventory as it spoils. And they don't want to buy too little because then they're going to disappoint their customers on high demand days. The manager has estimated that the daily consumption of salmon is normally distributed with a mean of 12 pounds and a standard deviation of 3.2 pounds. And traditionally, she's always bought 20 pounds of salmon each day, but the owner is concerned that this amount too often results in wastage. So to cut costs, the manager is considering buying salmon that is sufficient to meet demand on about 90% of the days. And again, we're given slightly different parameter values here. We have a mean of 12 and a standard deviation of 3.2. Okay, so the first question we're going to look at here is what is the probability that the demand for salmon at Little Ginza is less than 15 pounds given this distribution information? And again, in X space, what we're being asked is what is the probability that X, the consumption, is less than 15, less than or equal to 15. And hopefully, as you recall, this is a left tail situation. So that green region there, that is equal to 0.5 in area. We're going to use the table value after converting 15, that upper bound threshold here, into a z-score to figure out the area of this pink region underneath the normal curve. So if you take a moment, if you want, you can pause the video, but we needed to demean the 15 threshold X here. We have to divide it by the standard deviation. And when we do that, we should get a value of 0.94. So now what we're really being asked here is to find the area of, again, both the green and the pink regions together, where that Z value is set at a threshold of 0.94. And we know the green area is equal to 0.5 in area. That is where this term comes from. And all we need to do now is use the table to find that pink region. Okay, so we'll go ahead and take a look at our standard normal table here. And we can go ahead and find the value for 0.94. So note, here's the 0.9 row. Here is the 0.4 column. So we can go down there and we see we get a value of 0.3264. That will be the probability of the pink region in that diagram. So we can go ahead now and add that value there and do our summation. And we find that the correct answer here is 0.8264. Which again is the total area of that green and pink region there, corresponding to our Z value of 0.94. Now, this was, again, another example of the lower tail case that we concluded with in the last segment. What we're going to do next is take a look at an upper tail case, okay, using our distribution that was centered at 8 and had a standard deviation of 5. So now we're going to think about asking the question, what is the probability that X is greater than a particular value? Okay, so if X is greater than something, we're going to be using the right tail of the distribution. And again, first thing we're going to need to do here is we're going to have to take that threshold value of 8.6, and we are going to need to convert that into a z-score. So we're going to take this guy, 8.6, subtract the mean of 5, or subtract the mean of 8, divide by the standard deviation of 5, and that will yield a Z value of 0.12. So again, we started in X space. We are being asked to find the probability in the upper tail in this example, and we've converted the problem into Z space here. So I didn't draw the second diagram. I think we can just think about that along the x-axis. So all we need to do now is go to our standard normal table. We can look up that value corresponding to 0.12, and that'll give us the pink region. Okay, so if you want to take a moment, jump to your standard normal table and find the probability associated with the z value of 0.12. We can see here that comes out to, so here's 0.1, 0.12 gives us a value right here at 0.0478. So if we jump back to our diagram, we should be able to see now that that's not the area we're interested in this problem. Okay, so the table value, it's useful, but it's not the area we're being asked about. We want to find that light blue region, okay, which is equivalent now to asking the question, what's the probability that z is greater than 0.12? And in order to figure that out, we're going to take the entire area to the right half of the mean there, which we know this whole right half has to be equal to 0.5 in area. And then we're going to subtract the pink region out of it to leave us with the blue region. And once we do that, we are left with a probability of 45.22%. That is the area defined by this blue region. Okay, so this is an upper tail example. Now, let's remember back to our Little Ginza case study. The manager was buying 20 pounds. Okay, and we want to know now, what is the probability that demand would be more extreme than that threshold if she suspected that 20 pounds was too much inventory here relative to demand? That would lead to a lot of spoilage. So let's go ahead and ask this question. What is the probability that X is greater than 20? And again, to do this, we're going to have to take our X threshold of 20. We're going to convert that to a Z score. So we're going to subtract 12, divide by 3.2. That gives us a Z value of 2.5. Okay, and then we want to, it's, I think, generally a good idea to draw your picture. And that looks something like this. Okay, and again, this is an upper tail example here. So what we're going to need to do to figure out that upper tail value is we're going to use our table to find the area of this region, this white region right in here. And that's what the table value associated with the z-score of 2.5 is going to give us. So if we were to go ahead and look up that table value, I'm going to have to go down. So here's the row 2. And we actually want a table value associated with 2.5. And then there is no hundredths decimal place here. So we're really looking at this value 0.4938 as the area of that particular white region that I had identified a moment ago. So let's jump back to our picture here. We know what value we're looking for is 0.4938. And we can go ahead and substitute that in for the probability that z is between 0 and 2.5. Subtract that from the entire right half area, and that'll leave us with just the upper tail here, which is a very, very small probability, about 0.62%, which is choice A. Okay, so it's important to make sure we're interpreting that area correctly. And there are really 3 cases, general cases, I think, that we could boil this down to. We can think of the first case where we're looking at an event where they're asking what is the probability that something is greater than X, or at least X, more than X, or not less than X. Those are all narratively equivalent statements to each other. And in that case, if X was below the mean, okay, then we use the table value to find the pink region drawn in the diagram, and we had to add 0.5 to that pink region. Okay, the other case we could have been in is that X could have been to the right side of the mean like it was in that last example. Both of these are upper tail examples here. Okay, but in the right case, we're going to actually have to subtract the table value, which would be given us this white region here. The table value would be giving us the probability or the size of this white region relative to 1. And we would subtract that out from 0.5 to wind up with the pink region in the upper tail. The lower tail case that we started with, narrative being less than X, or at most X, or no more than X, not greater than X. There are probably more ways to say that. But this is the lower tail example, and if X is below the mean, then again, we're going to use the table value to get this region here. And we're going to have to subtract that table value from 0.5 to leave us with that pink region in the lower tail. On the other hand, if X was to the right side of the mean in the lower tail case, then we're going to use the table value to get the pink region, and we're going to have to add that green 0.5 region to the table value. Okay, last case, what happens if we're asked that the X is between two particular values, between X1 and X2? Well, if X1 and X2 are on opposite sides of the mean, then we're going to just look up the table value associated with each z-score, and then we'll add them together. The z-score for X2, we add that to the z-score for X1's table value. So I'm sorry, we don't have the z-scores, but we're going to use the z-scores to get those probabilities for both of those areas, and then we'll add them together. If X1 and X2 fall on the same side of the mean, in this picture it shows them both on the left, but if they were both on the right, we would use a similar approach where we would wind up having to get the table values. So the z value, when we convert X1 into a z-score, the probability value that comes from our standard normal table for X1, that will give us the areas A and B together. Okay, but then we would need to subtract out the area B, which corresponds to the table value for X2. Okay, so these are the kind of the three core cases here. We're going to look at a few more examples utilizing this approach. And here's a slightly different narrative to think about. The average prices of the C350 Coupe and BMW 2 Series are normally distributed. Mercedes believes that a $44,000 C350 is priced out of the BMW 3 Series 335i Coupe market. And the question here is, what percent of the dealer price for the Mercedes C350 Coupe is more than $44,000? Okay, so we're being asked, what is the probability X is greater than $44,000? And they're asking us to use here specifically the Mercedes C350 Coupe distribution. So I know there's a lot of information given here. We have two different distributions. We're being asked about the Mercedes distribution. So in order to solve this problem, we're going to do the same thing. Okay? Note this is an upper tail problem. We're being asked the probability X is greater than something. So we're in the upper tail case. And first thing we're going to have to do is convert X into a Z value. So again, I think it's always useful to draw our picture here. And since we're using the Mercedes distribution, I want to make sure I'm using the mean and the standard deviation that correspond to the Mercedes distribution when I'm standardizing that Z value. Otherwise, I'm going to get the wrong answer. And we note here that the Z value threshold is below the mean, which is why we're getting a negative 0.5 Z value. So again, the way we're going to solve this problem is we're going to go to our probability table. We're going to find the Z value for minus 0.5, and then we're going to add that to 0.5, which is the area on the right-hand side here. So that is the objective. Okay. So take a moment, go to your standard normal table, find the Z value that corresponds to, find the Z value of 0.5 in the row. You're going to go to that first column where there's a 0 in the second decimal point place to find the table probability. That gives you the pink region. You should add that now to the green region, which has an area of 0.5, and that will give you the probability that Z is greater than negative 0.5, which is 0.6915. And again, this is equivalent to the probability that X, the dealer price for the Mercedes C350 Coupe, is greater than $44,000. And it's a 69.15% probability. Next question. What percentage of BMW dealer are able to price the BMW 3 Series at more than the average price of a Mercedes 350 Coupe. So now we have to be a little careful. We're now being asked about the BMW dealer distribution here relative to the average price of a Mercedes C350 Coupe. And we know the average price of the Mercedes Coupe was $45,493. And this question's a little tricky. We're being asked, what is the probability that the BMW price is greater than that using the BMW distribution? So again, this is an upper tail problem, but we're using now the BMW's mean of $41,022 and the standard deviation of 2,367 to do our Z-score standardization. And you'll note now we are to the right side of the mean, okay, dealing with the Z value of 1.89. So what we're going to have to do here is find the table value associated with 1.89. Okay, that gives us the area of this white region. And then I can subtract that white region from 0.5, the entire right half of the standard diagram for that normal distribution. Now, take a moment. If you want to pause the video, fine. Go to your standard normal table. Find the value that corresponds to a Z-score of 1.89. And if you want to pause the video for a moment, you can. But what you should find is that that table value is 0.4706. We subtract that from 1/2, and that leaves us with that upper tail probability of 0.0294, or 2.94%. So the way to interpret this is that the probability that a BMW is priced above Mercedes average is pretty low. Okay, the probability that a BMW is priced above the Mercedes average is very low, only about a 3% chance that that's the case. Moving on. Okay, next question asks, what percentage of Mercedes dealers is pricing the C350 Coupe between the average price of a BMW 3 Series and $44,000? So again, in this next problem here, we're going to be dealing with the Mercedes price distribution. Okay, what percentage of Mercedes dealers is pricing their coupe between the average price of the BMW series, which was $41,022, and at the upper bound, we have our $44,000 other reference point that we're going to use. So the first thing we're going to need to do in this case is take each of those X thresholds and convert them into Z-scores. Okay. And note, again, always a good idea to draw that diagram. So we can see here both values are below the mean, right, of the Mercedes distribution. They are below the mean of the Mercedes distribution of 45,000. So we're going to have to really take two table values and subtract them like we saw on that slide with the 3 different cases broken down. So let's go ahead and convert our X values into Z values. And now we can reformulate the problem by really asking the question, what is the probability that Z is between -1.5 and -0.5? So at this point, what you should do is you should go to your standard normal table. You should find the probabilities corresponding to a Z of 1.5 and 0.5. Remember, it's symmetric, so you can use the positive values instead of the negative values. Find the table value associated with a Z-score of 1.5. Find the table value associated with a Z-score of 0.5. And then you're going to take the bigger one and subtract the smaller one. You're going to take the 1.5 table probability and subtract the 0.5 table probability. So the Z value of 1.5 should correspond to a table probability of 0.4332, and a Z value of 1/2 should correspond to a table probability of 0.1915. You subtract those two things, and you wind up with the correct answer that there is about a 24.17% chance of the Mercedes dealer pricing falling within that range. So correct answer here is choice C. Next problem, slightly different narrative here. We're considering an investment whose return X is normally distributed with a mean of 10% and a standard deviation of 5%. And the question is, what is the probability of losing money, meaning our return would be less than 0, our return would be negative. So that is what the question is asking. What is the probability we would get a negative return given the information we know about the distribution. So first thing we have to do is convert our x value into a z value. So I take 0 minus 10 divided by 5. I get a z-score, 2 standard deviations to the left of the mean. Okay, and again, we're going to use the table value associated with the z-score of 2. That'll give us the area of that white region right here. Okay, and we're going to subtract that from 0.5, which is the entire area to the left half of 0. On the left side is 0 underneath that distribution picture. So the table value associated with a z-score of 2 should be 0.4772. And we do our subtraction, we wind up getting an answer of about 2.28% here as the area in that lower tail. So this was, again, a lower tail problem. Okay, next question asks, what is the probability of losing money when the standard deviation is instead equal to 10%? It's a very similar problem. We shifted the parameters a little bit. You'll notice if the standard deviation's at 10% now, okay, our z value is only at -1 instead of at -2. Okay, so same problem, slightly different approach here in that we're going to use a -1 z value. So I look up the z-score table. Again, I go to that standard normal table. I find the row corresponding to a z of 1.0. I go to the 0, 0 column, and that gives me a table probability of 0.3413 for this area here. And I subtract that from 0.5, which again is the area to the left of 0 under the left half of that distribution, which leaves us with a lower tail probability now of 15.87%, a little higher. Next question, moving along. What we're going to do next is we're going to think about kind of utilizing the framework that we've developed here, starting in X space, moving to Z space, finding the probability. We're going to really ride that two-way street backwards now. So we're going to think about, in the next segment, how do we find the X value if we were given a particular probability first? Okay, so that is what we're going to do in the next segment. So we're going to think about answering the question, how can I find the X value so that only 33% of all values are above this particular value? So I will leave you here, and we will pick up with this example and wrap up our use of the standard normal distribution in the next video. See you soon.